So today we are going to discuss about the Java programming concepts, remaining like polymorphism and abstractions with example, and also we are deep dive on this method overloading. Okay, so because we will come to know what is method overloading in the term of polymorphism. So there, how they were being like implemented in the playwright methods, and also so there is a kind of one playwright topic called there is a web page, and in that web page we need to identify that links on the page, number of links on the page, and also we can print that link text and href value, and then after we can click one by one link and whether we can the link is working or not. Right. So these are the topics which I was planned today, and also there is a assignment 6. Okay. So by seeing that you will be able to understand it is a kind of inheritor. Yesterday, like we have talked about inheritance topic, right? The parent to child and superclass to subclass. So similarly, so we will use the real time. So suppose the person A created a class A and person B is created a class B, and A is extending B, which means uh, B person's B person methods can reuse in the A person something like so. So in the class A, you can define that HRM application, and the class B you can something like you can click on PMI link, okay, and you can extend B class to A class something. Okay, so just you can go through this and complete the task. Okay,
Okay.
yeah. So yeah. So today we'll deep dive in this the Java topic as well as the Playwright topics. So first one I told you, right, polymorphism. So what is a polymorphism? Okay, so what and how we can achieve the polymorphism in Java, right? So basically, poly is a sense of many forms, right? So by the definition we come to know. So it is a kind of a many form. Okay, so in a simpler manner, okay, in a simpler manner, so there is a one method. Okay, suppose there is a one method. Let's say that polymorphism in Java. So poly means many form. So we can write a one single method or a single implementation with a different kind of input, something like. Okay. So actually we have two types of polymorphism in Java. Okay, two types of Java polymorphisms. Okay. So first one is compile time polymorphism, right? And second one is runtime polymorphism or dynamic polymorphism. Okay, so compile time polymorphism. So when we say when it is a compile time and what is the runtime, so we'll go on learn. Okay, so before going to learn, so compile time. So basically, this compile time polymorphism, right? Yeah. So now what we need to come to know is we need a in detail about the methods. Okay, then we will to understand. Okay, so we must know that a declaration of methods. Okay, declarations of methods. How the method is going to declare. Okay, so what is a method? Method syntax. If you know very well, then it is very easy to understand. Right. So let me create a one simple example on method. Okay, so let me understand the method declaration public. Okay, public int. Okay, public int, and there is a method called multiply. Okay, there is a method called multiply, and the arguments are int a comma int b. Arguments are int a comma int b. Okay, and the method logic. Okay, so we are returning here return. Okay, return a into b. Okay, a into b. Similarly, I am going to create a one more method. Okay, one more method with another parameter into c, right? Into c. Okay, so this is the one, and I'm going to create another method into Same method name is same. Okay, float A and float B. Float A, float B, and double B, whatever. Okay, float, let's say, right here. Float B. There is a no. So let me understand it, here. You just need to focus on the method declaration. Okay. So here you see, let me highlight the things and understand it. Okay. So these are the methods. Okay. The first method is public int multiply. Okay. And there are two arguments and the logic of the method. Similarly, for the second method, same method name is same, but we have a kind of three parameters here. So this method contains two parameters, but method name is same. Okay, so method name is same, but here we have a different type of parameters. And the third method, so method name is same and different parameters. So this concept called method overloading. Okay. So this concept called method overloading in Java. So when you say method overloading in Java, in particular a class, okay, if it is a class, in that class we have a multiple methods and which are having same method name. Okay, same method name and a different kind of parameters. Okay, different kind of parameters and different order also. Different parameter, different type of parameters. So here all the parameters are int, but here is a parameters type is different and number of parameters also different. Okay, so when such a class having and those methods are overloaded methods, right? So when the overloaded methods, okay, so how do we know which one to be execute? Okay, so how we come to know when which one is executed? Suppose if I write I'm calling method. Okay, I'm calling a method multiply. Okay, sorry, just I'm calling a method. So let us take the class name. Write a class name. the Class name test. Okay, so I should create a test object, right? So test t equal to new test object, and I want to call t dot method multiple of. Now you see when I pass the type of parameter. Okay, suppose if I pass 10 comma 10 comma 10. Okay, so then compiler, so this 10 means which is all two integers, right? So this must be integer, okay, and this must be integer. What is that? Yeah. 1 second. Right. So now a compiler come to know in a compile time which should be executed, which one should be executed. So based on the compile time, okay, when this code is compiled, so automatically take the decision. Okay, these two are a integer type data. Okay, integer type data. Then this method will be executed. So this method is executed for selection. Suppose if we pass a values, or suppose if I pass another method, and same method name is same, right? Multiply of 5 comma 2 comma 3. So then compiler automatically look for that. Okay, this multiple method having a three parameters and three must are integer. So then it is this one. So this one is decided to execute in the compile time. Okay, so that is called we called when the method overloading is there. So that is nothing but a compile time polymorphism. That class is satisfying the compile time polymorphism, right? So that's what. Suppose if I call the method multiply method t dot multiply, okay, t dot multiply of floating point, right? 10.0 comma 20 point, okay, or 50.1 1F. So then the compiler decide that, okay, so compiler decide that it will execute this one, right? This is the one. Suppose if I pass the value or if I call the value t dot, okay, t dot multiply of 10 comma 2 and hello, okay. So will this method is declared?
No.
No. So the compile time it says that compiler error. Okay. So there is error for such method is not declared. Okay. Such method is not declared. Compiler throw the error. Okay. So this is the one. So we compile time polymorphism implementation. Okay. So what is the compile time polymorphism? In a class, we have a method name is same and different type of argument and different type of argument, different order of arguments also, number of arguments. Order must be different. Okay. So then we come to know this class must be method overloaded. Okay. So this method overloaded functions we can see a lot of. Okay. So in real time, in our testing case, right? So there is a search box. Like yesterday I told you, right? There are search box and on the other side we have some check boxes, right? There we can our method names must be search. Either it can be price filter, or either it can be age filter, or it can be area filter. So depend upon that, search must be single method, but we are overloading a different kind of method. Okay, and method name is same, but in the logic inside the logic must be different. Okay, the result of method is would be different. Okay, so that is the one. Let's explore more on that. First, we'll create one program. Okay, so method overloading is on. Okay. And let's create a new method. Okay, and so public void, and our public int, right? Multiply of into a comma into d. So every time we start with. Now similarly, we can create another method, and the type is to C, right? And the logic is okay. So there is another method. Okay, so multiply, but a different type of parameter. Float a comma float B. So let's remove the logic C. Okay, so this is the way it is created. And so when I create an object, so when I create an object creation like that by using the constructor of the method, right? So suppose method overloading equal to new constructor, default constructor, and method overloading dot multiply. Okay. So whenever you pass and comma empty, it says that okay, compile time. Automatically the compiler decide that okay, right, you pass that integer, so it is there in the integer. So it is highlighted. You see, highlighted. So suppose if I pass like a dot 0f. Okay. So now you see this one is selected. Okay. So why it is selected, even though it is a int, but here it took right. Okay, because there will be it will treat that there is a dot automatically. Okay, that is the case it treated. Instead of if I call here a string, now it will throw the error because here it is expecting a float, but we pass a integer. So then the compiler is throwing the error. So which means the compile time only decided which method to be executed. That is called compile time polymorphism. Poly in the sense many form. Your method multiply method is a many form, and so which can do some different kind of argument, which have different type of argument, different order of the argument, and but even though a different implementation, but method naming must be same. So then we call it a method overloading. Okay, method overloading. So by method overloading, we can achieve the compile time polymorphism. Okay, I hope it is understood, right? Yeah. Let me run the program.
It was showing why it shows error on 12th line, Nagesh. Here, written it.
12th line. Yeah. So our data is a floating. We are adding a float data. So again, our return type must be float, not int. That is the reason. Yeah. So now it is executed.
So
Okay.
we can write this method without return type also, right? Is it return type must float in?
Return type. Yeah, return type is not must. So we can
Okay.
give void also. Okay. If you void it, you can just type like this or
Okay.
save the. Okay. Okay. This is also fine. So
Okay.
this is already there. So suppose the test. Okay. This is integer type. The result must be like. Okay. Okay, so for better understanding, just I created a type of methods. We can type of float and int. Okay, now next one is runtime polymorphism. Okay, so this is a kind of tricky, and we need what parent-child relationship as well. Okay, so that is the encapsulation. Yesterday we discussed, right? One class A and class B, something like. Okay, so let me create that one. So let me create a one class called parent test class. Okay, my class name is parent test class. Okay, Mm, let me create a method on get. Method name is p test. Okay, the simple name p test and sys out. It is a parent class method. Okay, parent class method. And there is a one more class, one more method, public void print method. Okay, print method. Okay, so now parent class print method. Now you see there are parent class which is having a two type of. Okay, this is a parent class. In that first one is a parent level method p-test. So there is another method called print method. Okay, so there are two classes. Sorry, in the class two methods. Okay, so now I will going to create a one more class, a child class. Okay, so let's see that child test. Child test. Okay, child test. Now here I will create a same method, this print method only. So let me create a public void print. Okay, so print method sys out, correct, and it is a child test class method, child class print method. Okay, so now there is a new method in child test. So now you see that if I create an object, okay, so object child test object equal to new child test object. Now I can access child test class of print. So till now we know. So this is an individual class, and this class having a one print method, and the in the main method we created a object of the child class test, and we are calling a print method. Then we can run this one. Okay, so we can run this one. We got the output of this. Now you see now what we are providing that for runtime polymorphism. So we child class, right? The child class must extend of parent class or parent test. Parent test. So parent test having how many methods? Print method as well as a p-test method. And you see the print method of, okay, just I'm copying this one. Print method of child one and parent one are mostly same. Okay. So this below one is a from parent and above one is child. So the difference is the different implementation. Whatever the in the body, the implementation is different. But method name, method return type, everything is same, right? It is a kind of polyform. Okay, so it is a kind of polyform. Now, so now the relationship now, parent class having a print method, but parent has own implementation. So currently the print statement is it is a parent class print method. Okay, but in the child class, the same print method, the implementation is override. Okay, the child class is override a parent print method. So what does mean is, so as we know, whenever we do this extents of a class, which means it is a parent class. Parent class, how many functions we have? Two functions. Okay, automatically the child class we should get it automatically because we implemented the inheritance reusability. But even though in the one method, okay, so this print method, the child class, you don't want the parent implementation. So parent implementation in the sense parent return logic is not sufficient to, okay, parent method logic is not sufficient to child because some functionality is enhanced. So he want to override that time explicitly he will write the method implementation. So because you see p-test is not implemented because it doesn't require same p-test can be used by the child class. So let me now you can see that. So if I call child class test, okay, child class test of p-test, okay, and the child class test p-test in the sense child class p-test. Where is the p-test in the child class? No, right?
No, it's
P-test. P P-test is the parent test. Okay, P-test is the parent test class of method. So in now you can see that we created a child object. Okay, we created a child object, and we are calling of a parent method. So this where it is in the parent class. So that's what is the logic of it. Now, if I call parent, if I call child print method, okay, so this object, child object of print. So now I can see that this child class print only executed. So let's see that, and I will show you the some kind of implementation. So this is runtime. Okay, it will decide the runtime which should be executed. Okay, clear. So this is a simple way. Okay, whether P is a parent side and print is a child side. So there is another way of creating an object. Okay, so there is another way of creating object. Now parent class object. I'm creating a parent class object p-test. Okay, and parent class. Please listen carefully. This is a kind of quite confused and little bit complex to understand. Yeah. The first one is clear, right? We created a child object, child class object, and we ran that one parent method, okay, because it is extended, and inside that we call a child method. Cool. So now, especially we created a parent method. Okay, parent object, parent class object. Now, parent class object also we have a ptest method and parent class object with print method. Now this time, okay, there is no confusion. So P in the sense it is a parent side, okay, and also we have a parent class object, okay. We are going to call a parent class print, okay, print method. So this is a no confusion. Okay, similarly, okay, it is a parent class method and parent class print. Now there is another way. Okay, there is another way. So now you can see that parent class reference, but we are creating a child class object. Okay, so you see, let me highlight for better understanding. So this, okay, so this is the way. It is from parent, it is from child. Okay, so in this case, all from the parent, all from the child. Now we are creating an object like parent reference is pointing to child object. Okay, child object. So let's see the what will happen and then we can see. Okay, so let me clear the diagram. Ah, right. Now, now I'm parent dot ptest and parent test dot print. Okay, so let me add some kind of SO output.
I think object name, do we need to change the object name?
No, we haven't seen the object. We mapping is changed. Let's see. So I will explain. What was the other? Line number 21. Okay, same parameter is there. Okay, I will make a one more. Where a variable reference already we used, right? Yeah. So that is this. Yeah. Now we can see the output first carefully, then we can discuss, right? So let me yes. Now we can see and we can highlight it. The first one is parent child object, okay? Child class object and calling one parent class method and one child class method, right? So similarly it printed parent class method and child class method. Okay. So second one is we created a parent object. We created a parent class object and both methods are in the parent class. So that is the case. It is a very fast clear. The output is parent class two methods are executed. Right. Now this case we are reference. Okay. So we are child class object. Actually, this is object and this is a reference. Okay. Okay. This object is created in the sense in that I told you right that memory okay. Let's take the circle. Yeah. In that memory, the object is created and all the child class related information will be there. So what is the child class information? So print method is there. Okay, which one is there? Child one is there. Okay, which one is the child one is there, and it extended, and also it is a parent test is there. Okay, parent test is there. Okay, and also it has a parent print method also. Okay, so parent print method is there. But you see, but it decide that okay, even though like yeah. So now you can see this is a parent reference. Okay, parent test is executed, but it decide a runtime. Okay, it decide the last one is a decide the runtime. So it runs that child class print method. Okay, okay. So even the parent reference, but the object is referring to child, then child class one is executed. So this is nothing but a runtime decision. Okay. So runtime polymorphism. Runtime which come to know which one method, parent method or child method to be decided to execute. So that is called runtime polymorphism. So here, by using this print method, we have two prints, right? One is a parent level print method, child level. Okay. So sometimes we need a parent print method. So that is the case when that time what we should do, we have to create a parent object directly. Okay, parent object only you have to create and call the parent method if you want to use. Either you want to use a child class print method. That time you can try to create a child object directly. Either you can use parent reference and along with the child object. So this way also it works, and we decide that actual object in the runtime it will be decide which class method should be, like which class method in print method to be executed. So this is taken care by the runtime. That is the case we call it a runtime polymorphism. Okay. Yeah. Yeah. I think in 1 minute